Good morning, everyone. Thank you for showing up to a session about accessibility and how Java and Java applications can help to have accessibility. Well, let's go into it. We have about 50 minutes to dive into this, and it's the first time that I am delivering this, so let's hope it's going to go all well. Bueno, estoy muy contenta de estar frente a vos. Puedo hablar un poco en español, pero mi español está aprendida sobre la oreja. No es un español aprendida en la escuela. Pero estoy muy contenta de estar aquí una vez más a DevBcn. I'm Anna. I'm currently working as a Java developer advocate in the Java team at Oracle. I enjoy sharing content and best practices with Java. Today I'm going to share about how Java can empower accessibility with different APIs, with different practices, and with different tools. And I would love to talk to you more about Java. And you can contact me on social media. I am present on various social media networks, on Blue Sky, on X, on Mastodon, and ask me more about the topic of today, but also about other topics in general about Java, and anything that concerns you in your Java developer related life. So pretty much I love everything Java and anything that can be integrated with Java, especially if it can be integrated. I'm really keen on making some interesting integrations with Java. But let's get into the motivation of the talk of today. Accessibility, if we are all, let's say, if you consider yourself perfectly healthy, then you might not see accessibility as something mandatory. You would see it more as a compliance factor. But actually, accessibility is about inclusivity, about having ethical design within your application. And, well, let's say the reality that hits us is that, according to World Health Organization, more than 1.3 billion people live with a disability. So that's quite a lot of us that are not 100% considered to have all abilities. So we need to think about those 1.3 billion people when we are creating our applications as well. And before going further with explanations on accessibility and all, I want you to think about your recent experience in your past month, let's say. If you ever experienced issues navigating a website, maybe you're on a mobile and there's a button that jumps all over the place and you're just trying to find it so that you can submit it. Or you had to repeat an action to make sure that is done. Can you please raise your hand if you experienced this in the past month? Well, we're almost all the people here in the room. So I would say that even us that are working in this field of IT experience accessibility issues, and we're getting frustrations with this, despite being here and feeling good about being technical people. So accessibility is for all. We need to think about everyone. Now, digital accessibility's definition, the best that I could find, is making sure that everybody can perceive, understand, navigate, and interact with information on the internet. But this talk is going to touch also what's not on the internet. So accessible software actually, if you're thinking about it, you're thinking that, well, accessible software should be there to help folks that suffer from something. Folks that suffer from visual impairments, for example. Folks that have auditory impairments, moderate mobility issues, or people that have cognitive or intellectual impairments. So, and even people that have seizures, of course. So we need to make our applications equal to everyone. Hence the goals of this talk. We need to look into what's Java's role in accessibility, what Java brings to us. What's the impact of the API design that we are doing for our applications, and how documentation of our applications, of our libraries, can impact accessibility. But mostly, how we can use AI, because that's the trendy topic of today. Like, AI can help and do anything. Even the toothbrush that we're using probably is powered with some AI in it and knows which teeth should clean better. But how we can use AI to augment the experience of everyone when they're interacting with our applications. And let's get first to what's the state of accessibility today. So we know there are about more than 1.3 billion people that live with disabilities in the world. But We also kind of acknowledge that accessibility benefits everybody. And just to give you an example, closed captions. I'm not talking about subtitles, I'm talking about closed captions. If you have ever had the curiosity to, let's say, go on YouTube and enable the captions, you would see that sometimes you get that description of the dialogue, like X has gasped, or Y has shouted, or shouting. Those are captions. Those are helping people that have problem with auditory impairment or have auditory issues. So this can help in improving the perception of something that is happening with a specific application. And well, to help and have some sort of guidelines on how we can achieve accessibility as developers, we have the WCAG guideline, which stands for Web Content Accessibility Guidelines. And some people think like, okay, so if my application is not on the World Wide Web, it can be accepted from accessibility, right? We can forget about it. So if it's not seen on the internet, we can forget about it. But actually, the same set of rules could be applied even for our desktop applications. And of course, for those applications that are on the internet, there are some legal consequences. There are authorities, there's authorities that can apply the law and can fine those specific, let's say, e-commerce websites or those websites that are not accessible to everybody. Now, in USA, there's Americans with Disabilities Act, which is called ADA, that also applies to digital applications, by the way. So that one can be used in lawsuits in the United States as well, if an application is not accessible. But for us, for Europeans, something happened on 28th of June, 2025. The European Accessibility Act became effective. What that act means is that the e-commerce websites need to have at least the WCAG AA level. I'm going to reach and explain what that means in order to become accessible. Otherwise, the companies are risking some fines. So minimum AA level to be accessible for everybody, us here in EU. This happened, I think, 2 weeks ago. But this didn't happen in 2025, and we just learned about it 2 weeks ago. This was announced since 2019. So we had, as developers, we had 6 years to prepare to become accessible and to enhance our application. But I can place a bet that for sure there's somebody who has just heard about it and will just rush into making the application accessible. But what does it mean to be accessible? What those principles of accessibility mean? So we had that definition about what accessibility means, but the principles that make the foundation of accessibility are the 4 that you see here. And what they actually say is that nobody should miss out something on an application due to how they access the information. So everybody should have equal access to the information regardless on how they access. All essential functions of an application should remain accessible regardless of the tool that the person is using, regardless if you're using a laptop or a mobile device. Your content and your interface should be easy to follow, should not have any confusion, misinterpretation, and other things. So this means on the long way that all the users must be able to access the content that you're producing or your technologies that you're making as you advance them, and regardless of how advanced and cool and nice they are. And I spoke about WCAG levels. So these are the levels that we have for the Web Content Accessibility Guidelines. Now, level A is the basic one. And what some e-commerce websites have done so far before 2025, 20th of June 2025, everybody was aiming for A, for basic level. So the basic level meeting that one means that you have no significant barriers on how your users are accessing your content. So this level kind of requires text alternatives for your videos, for your 3D models, for your images, or making sure that anything interactive in your website is keyboard accessible. Now, level AA, which is above this one, includes all level A requirements and more criteria, meaning there's a contrast ratio of at least 4.5 to 1. I'm going to demonstrate how you can do that for text. Providing text alternatives to images if those images are not loaded, or ensuring consistent navigation throughout all your website. And the last level, the AAA one, is not just AAA and means it's hard to get. It also means that your software is going to be accessible to the majority of users out there. So that's how you should perceive AAA. It means that your website is going to be given to everybody that can access the internet. Criteria of this level means that, well, you have some sign language interpretation for your audio content, or you are having a contrast ratio of at least 7:1 for your content, or you're offering extended audio descriptions and multimedia content so that people can get to that. And we have these levels, again, to make everything universally accessible. And it's not me who said that, well, everything should be universally accessible. It was the creator of World Wide Web that said that everybody should have access to the World Wide Web. That's why the internet and World Wide Web was invented, so everybody can get to it. Otherwise, we would still be just on our tiny portables and doing our own things in our own bucket there and not talking to the other people. We want to interact. We want to be connected with everybody else. So, how do you know that your application is accessible? How do you get to that? What tools are there to assess accessibility, right? And I compiled a few tools and technologies. So most of the time, the tools that people that have disabilities are using to access your application or to work with your application, to work with your website, to work with what you're doing, they're pretty much the testers of how accessible your application is. And I just gathered a few of those there for desktop apps and for the web examples. As you can imagine, most of the web ones are based on browser extensions or features that the browsers are having so that you can test your application. All in all, what universal accessibility tools mean is that a wide range of technologies that are designed to make all the environments usable by everyone, regardless of accessibility. And this is just a few examples here of tools. Sometimes there are tools like JAWS, for example, that can do multiple functions. Like, for example, JAWS can do screen readers, but also can do the testing and give you some feedback on that. So that's one of the good things there. But all these tools kind of tell you things about look and feel, like seeing, touching, interacting, right? This feels like front end, right? And Java is for back end. It's not for front end, right? Well, there's a myth. Accessibility is just for front end, but that's just a myth. Yes. Well, screen readers, color contrast, keyboard navigation, focus, they all start with the front end. But accessibility starts much earlier than the UI layer. It starts with the way that you design your product, and that's when all the team is coming together. It begins with thoughtful user experience. That's why I asked you in the beginning if you experienced any navigation issues, if there's a button jumping somewhere, you had to press submit 2 times and so on. That's bad UX. That's how we call it most of the time, bad UX. But that means lack of accessibility as well. So that's when you start thinking about how accessible your application is with the user journey. And you don't, and as developers, we start with maybe the happy path, the perfect path, when everything works perfectly. But we should think about, and we should anticipate the diverse needs of our audience as well. Now, for the back end, we held the responsibilities by the way that we're doing our libraries, the ways we're doing our APIs and data structures. They must be accessible too, and there was an amazing talk done by Victor Renta yesterday about pitfalls of REST API design. So those pitfalls have impact also on how accessible your API is. So that means that sending clear, meaningful error messages or having semantic field names for your APIs, for your libraries, have supported assistive tech-friendly formats when you're processing data, or properly label that. That is important from your point of view as a back-end developer, as a data manipulator developer. And last but not least, documentation is important. And documentation affects us all. And just to give you an example of documentation, Last week, I reverse engineered on how to connect from a mobile application to my washing machine because the washing machine maker released a new model. But why update the help? And why update the tutorial that was on the internet? And I was searching for the home while I didn't have a home in the menu. Now, imagine there's a grandma somewhere trying to do the same thing, and they probably will not manage to achieve that without calling for some granddaughter or grandson to help them. So help content, labels, tooltips, API docs, those are important, and they should be written in plain, inclusive language that supports a variety of learning styles and comprehension levels. Always think about who are the users that you try to address to. They're not just your colleague that works next to you and knows perfectly the API. There's also people that didn't have the same preparation as you did in school for becoming a developer. But also, another important aspect for accessibility is translating the content. The quality of the translation and the translation that you have for your content is important as well. And that one sometimes is spawned from the backend. And to give you an example of how impactful is something that you do with your REST APIs for accessibility, let's say the REST API that is returning epoch timestamps without any labels makes those date and times meaningless for screen readers and for voice output manipulators. So really think about on how screen readers and all those tools that you saw before would interpret the data that you're sending from the backend. And now let's get to the meaty part. What's Java's role with accessibility? So where did Java bring to the accessibility part? So Java started really early with accessibility and brought it with Swing. First of all, there's Java Access Bridge. Java Access Bridge is a tool available for Windows. It acts as a bridge between Java apps and assistive tech like JAWS or Narrator. So this one is something that you can enable on the Windows, and you can test for accessibility tools to function properly on Windows. Now, Java also comes with Java Accessibility API. Now, this is a core API that is in the JDK and lets your application, normally your desktop application, that's why I said this session is both desktop and web, your desktop application expose meaningful components, info like labels, states, roles, and more, and error keys to assistive tech. So this is being, if you're using Swing, for example, the Java Accessibility API is being built in that. So the screen readers can access elements like buttons, menus, and toolbars, and Swing is still used in applications that function on our desktops, I must tell you. Now, there's also Java Accessibility Utilities, which is a set of classes that help assistive technologies provide access to graphical user interface toolkits. And overall, Java lets you decouple the UI appearance from logic. Now, this is mostly for the model view architectures, and some of you will say that's the old style. We're going to talk about that old style that is still present nowadays. Technically, yes. The Java Swing applications, the JavaFX applications, they're mostly Java's model view architecture kind of followers. And speaking of JavaFX, well, JavaFX also has accessibility supported natively through platform bridges. Now, in JavaFX, accessibility was mapped as following. So I need to tell you a little story. The underlying operating systems that we're having on our computers have many of the same concepts around accessibility. For example, all platforms have concepts like roles, like attributes, actions, and notifications. And in the many cases, these accessible concepts map one-to-one with the concepts from JavaFX. That's why you see this lovely slide here. For example, every accessible control has a role that the screen reader can use to tell the user what kind of control is active. The screen reader can also use that role to decide how the control can be addressed. So how do you interact with the role that comes with your operating system when you are in JavaFX? There's a fundamental API for that. So that you need to know. The API for JavaFX, when it comes to accessibility, just with these 5 that you need to bear in mind, it helps you with a few things. So the first one is about providing a role. Normally, when a role is provided for a node, the screen reader speaks the role as well as the contents of the node. But the role is given through an enum called accessible role. That one is set in stone, so to speak. And imagine, for example, that you're doing a game in JavaFX. If you're doing a game and you have, let's say, you're doing Pac-Man and you want to specify a ghost. A ghost is not exactly a button, right? Or any other type of JavaFX sort of control. It's a ghost, right? And how you can say that to the screen reader that that's a ghost? The way you can do that is by accessible role description property API. So you can just give more details and say, hey, this, well, I set it to a role, but actually a ghost. So that's where you can give more details for the screen readers to interpret and so on. Accessible text property is great when you need to give more information and to give the text property for specific labels, for a specific checkbox, and so on and so forth. So think about, like, if you're setting a text property in your JavaFX application, you should also set your accessible text property as well. And obviously, what I missed for my washing machine, the help. The accessible help property is where you give a lot of information about help. So that's where you can give more information on how bigger components are behaving. And speaking of bigger components, there are controls in JavaFX that do not necessarily fit in the categories above, and maybe you want to give a more overview, and that's when you can use label for property API to give that more meaning, to offer description to what's happening to an image view, to a slider, or a progress indicator. So let's see some examples. First of all, accessible rich internet application roles. Those are helping the screen readers understand what's going on with the elements. That's why we need the roles. We need to add area roles to communicate the role of the component to assistive technologies, making sure that the application is more accessible. And the way to do that, for example, in JavaFX for a button is to use that set accessible role button. That was easy, right? Pretty easy and straightforward. You start with role. Now, you also need to give an information about the structure and the meaning of the content. If you are a person that doesn't have any visual impairment, that works. You don't need to guess that something is like a table or there's a structure of web. You can see perfectly, right? But for people that have visual impairments, you need to give more information about that. So in web development, we use semantic HTML to inform assisting technologies about the structure and the meaning of the content. But for Java desktop application, we need to ensure that the user interface components are structured properly. And we can use layout managers for that, or layout containers, to allow the interface to adjust semantically instead of using, the pixel type of setting. So try to avoid setting sizes in pixel and try to render that accordingly to how the screen could scale. The third one, I think I spoke about it also for the web, to implement keyboard navigation. Keyboard navigation is vital for users who cannot use a mouse. It can happen. So always maybe unplug the mouse from your computer and check if your website or your JavaFX application is accessible through the mouse. Now, for JavaFX, you start with setting the focus to use focus traversal, and then you can use key bindings. So for key bindings, you are giving custom controls. Now, in this example, we make the start game button fully accessible via the set focus traversable, and then we add a keyboard event listener, so it responds to either enter or to the mnemonic shortcut of S. And lastly, we set the accessible text to help the screen reader announce what the button does, right? Because it's not enough just to say this is a button and so on. It should also say that it starts the game for the screen reader. Another one, setting the color contrast. Now, it's important to choose a good color contrast, and that, for us as backend developers, can be challenging. Like, how do you know which color contrast works, which one is meeting those accessibility levels? So for this one, I just set these colors here, and some of you are like, OK, you have a lucky guess, maybe it works. But how did you know that it works? Well, there's a nice website that's called WebAAM Contrast Checker to test colors combination. And I'll provide you the last slides, and you can use the link there. Pretty much cool. And hoping that the internet is working. So this is the contrast checker that you see here. And remember that I was saying that the levels have a certain contrast level that you must reach? Well, here's what you do to see the contrast ratio that the levels want from you. You do this, you do that, and you can see the contrast ratio. And you can also see which levels of accessibility you can pass with that contrast ratio that you set there. So pretty cool, available to everybody, is not very difficult to use and so on. Now, I did test my contrast checker for my game, and it was through this website. So remember that. Now, for dynamic content handling, that's another story. So whenever you update the content for your application, you should also think that the screen reader should read that update as well. And you can do that to accessible text all the time and not forget about that. So for example, if the game has started, the state of the game has changed, you update that for the users that can see the label of in the game has changed. But also you should set the accessible test that is also with the game started, so that they would know that the game has started as well. And moreover, there are ways to override, to interact with the screen reader in JavaFX. So there's a more advanced way to work with accessibility in JavaFX by overriding these three methods of nodes. So there are ways to customize how a node is behaving. For example, if a different state is requested, depending on the role of the control, if something has changed over there. So this is something that you can override in your application, depending on how the control state has changed, and tell the screen reader that these have changed as well. Now, the cool thing with JavaFX accessibility is that if a user doesn't have a screen reader, there's no overhead coming from setting all these accessibility options. So there's no extra layer of burden for your Java application when you're using this. And if you want to make an element traversable only if the accessible property is active, have good news as well. That is also possible because it's platform available. So accessibility of being active is something that is platform dependent in JavaFX. It's not something that is set from the beginning, and it's not something that you set once and you can modify it. That's the JavaFX, let's say the desktop side of the world, and we can control as Java developers. But can we influence accessibility for web applications, like for applications that are on the internet, our e-commerce applications, let's say? Do we have any influence as Java developers there? Because those are not necessarily JavaFX, right? Or Swing. When moving to the web, accessibility practices, they kind of move to the segmenting HTML and dynamic content rendering. And you need to maintain the inclusive experience across browsers. So that's the main thing there. But the thing is, a couple of years ago, something became popular. It's called server-side rendering. We used to have server-side rendering in Java. We had it with the applications that were JSPs, there were JSFs, right? So we had it for a couple of years, but we moved from that because we realized that front-end is much more powerful on rendering client-side, and there's some heaviness if we're controlling things from the server side. But server-side rendering is actually that's helping a lot when it comes to accessibility, and it's still valid nowadays. There are many applications that are using Spring Boot with Timeleaf, and they're available on the internet. They are not microservices, but they're still using this kind of technique to render their content, and they need to be also accessible. And this server-side rendering way of working kind of helps because you avoid dynamic content rendering issues that usually occur on the JavaScript-heavy single-page applications. And you can give better experience to your users with cognitive and visual impairments. But again, because of server-side rendering, you are in full control of that. And I spoke about content a lot. And I want to give you an example of an architecture where server-side rendering is very meaningful nowadays and is very present because it's a product that a lot of people are using. It's a Java-based product. I worked with it as well a couple of years ago. And I can explain why it's relevant. In e-commerce, it's pretty common for applications to build platforms that have content management systems, right? Because you want to be able to beautify your website depending on your promotions and whatever you want to offer to customize to your end users. You want to sell, right? And to sell, you need to build things really quickly and beautifully. And yeah, you cannot hire a bunch of developers all the time to do the graphical user interface all the time in JavaScript. That will be like time-consuming. You're not fast enough to the market. So all the time, you would spend a lot of time rebuilding your graphical user interface. Now, content management systems are good. But traditional content management systems, they're like you are making some components, they're HTML rendered, and so on. However, e-commerce platforms, because they sell, they usually have a payment module. Integrating a payment module in a CMS is not scaling well, I can tell you from experience. Imagine that you're having some promotion, then you want to, there's a lot, I don't know, 10,000 euro, 10,000 people going there trying to buy something in the same time. It's going to be a mess if you try to do that integration over there. The reason why it's not scaling well is because content management systems traditionally, they have a modular monolithic architecture. So they're good at offering static HTML, but they're not that good at coping with many integrations with other services and so on and so forth. So what Adobe did with Adobe Experience Manager, they offered multiple types of offering content. It's a whole full stack, the traditional HTML kind of thing. There's also a headless. And the headless, what it means is like, OK, there's somebody in the CMS that doesn't have technical abilities of a developer that goes and drags and drops components, but that is also translating as a REST or GraphQL API. So what that means is that the content management system is exposing both HTML, but also can expose a nice API that can be consumed or can be unified with other responses from other services to be offered to the interface. And what traditionally people are doing, they are combining this in a backend for front-end application, for example, unifying these responses, and then they're configuring the front-end with that. Some of you might say, my God, this is a lot of work. It is a lot of work, requires a lot of finery. But again, it's something that really relates to how you are designing your backend and you're influencing your backend. Now, if you're doing this kind of server-side rendering and hybrid content delivery in Java, you are also responsible as a Java developer to instruct via that API, that REST GraphQL API that is driven by your Java components, on how the web is going to interpret and make that accessible to users. Now, this is pretty nice kind of architecture because it offers better performance and accessibility. HTML is delivered early. The JavaScript behavior is added progressively, and it retains kind of the benefits of headless CMS, but also it gives you a lot of accessibility to it. And I can tell you from proper experience, I've done this with GraphQL. So server-side rendering with GraphQL, and also working with microservices because, well, unfortunately, it was not working for everything to be microservices. When the customer wants all the time to change their front end, then they want to make it more dynamic all the time, depending on their offerings and what they're building and customizing throughout time. And they don't want to pay making a microservice every time they make a promotion. So that's a little bit of the server-side part of the Java. Now, speaking about inclusive API design and documentation. We'll start with documentation. Why documentation matters for accessibility? Well, accessibility, we want to be able to understand what an API does, what a library does, and helps us as developers to implement features correctly and how to integrate with an API, obviously, but also communicates better the intent and the behavior of APIs and the components that we're doing to assistive technologies. The tools that guide accessibility I think we know them. They're called JavaDoc. And we know that Swagger and OpenAPI. So with JavaDoc, you can explicitly describe how Java components can handle focus, for example, or keyboard events, or how screen readers read output. And well, with OpenAPI, for example, you can build on how your API is going to validate the input, and how the error messages are being handled by your API. So this is also equally important to make your API accessible. To write documentation with inclusion in mind means these 5 things, in my opinion. It's about making documentation that's clear and predictable. Your documentation should make it obvious to the users how they can interact with your application, with your API. Write for developers and know your audience, but also write for those developers that are using assistive tools to work with your API. Also use consistent terminology. So speaking from, let's say, front-end experience, don't use action, use what it does, submit. Document the area roles and include accessibility requirements in your API contracts. So, and by the way, if you're using tools like Swagger or you're making HTML JavaDocs, you can also customize how the keyboard and the screen readers interact with those as well. Now, prioritizing semantic API design for accessibility is very important, and how you can achieve that if you're using meaningful descriptive API endpoints. We're tempted all the time to give some extra names to our endpoints because, well, we like to have them shortened, maybe, but giving meaningful names to our endpoints helps accessibility as well. Semantic endpoints are helping screen readers and other assistive technologies to give the necessary context, and also are helping developers as well because they will understand what's actually given by that API. Thirdly, you should use standardized formats, and that's where JSON, GraphQL help us as well. But as I said earlier, using standard keys like error, message, data, and so on, it helps improve the user experience, especially for those that are using screen readers. And of course, think about supporting multiple input methods for inclusive access. So, for example, for a form, you might think that's front-end processing, but it's also going to be processed on the back end. So you have to be prepared on how the processing of that form, of that multi-part form, is going to be on your back end as well when somebody with a screen reader wants to use your application. And probably one problem that a lot of people have, a lot of people that with disabilities have, is authentication. Authentication is considered a common barrier when it comes to using applications. People that have cognitive and visual disabilities are not often taken into consideration when login flows are being created. So traditional CAPTCHAs, the CAPTCHAs that we've seen on the websites, for example, they're exclusionary to people. And we should offer recovery paths and clear feedback errors to the people that are having disabilities as well. In this case, biometric and social logins are better. But also, multi-factor authentication can also assure multiple and various user needs, including those with disabilities. So think that you're also making a service to your security team, but you're also making a service to your users as well. And of course, as always, use clear, concise language when it comes to authenticating to your applications. Finally, on this part, I would like to say that accessibility isn't just not one-time thing. Achieving AA level is not a one-time thing. So you should consider having it and integrating it in your development lifecycle. There are tools like Axe or Playwright or Selenium that you can create tests with, including your CI/CD, and you can get feedback from those. But most importantly, get feedback from real users. Real users are going to give you feedback that something is not accessible when they want to use your application. And there used to be a practice of hiring people or having folks testers that have certain disabilities to make sure that your application is accessible. It's a good practice as well to test that application is accessible for people too. And there are tools, of course, for analytics as well, like Wave and screen readers, to look into the analytics and how your application has behaved. Now, from my own experience, working with Playwright is pretty cool, because with Playwright you can create not just tests and have results, but you can also think about having reports and create like a monitoring diff of how accessibility has changed throughout time for applications, because, well, I assume that the things are going to change with the applications and they evolve. But how do we use AI to augment accessibility, right? So how do we use the lovely, this new tool that have a lot of capabilities nowadays, and we have large language models and more ways to tackle different problems of the world? Well, accessibility is a human-first goal. But AI is also great because it's just powerful and can be used to have thoughtful accessibility design. So natural language processing is pretty cool because it can adapt text dynamically. Screen readers can read simpler summaries if you're using AI, or real-time captions from audio input. And you've seen that, for example, YouTube is using a lot of AI in their tool to help improve the experience with the app itself. It also offers translation. So natural language processing, in my opinion, powers voice-activated assistants and can enable those that have mobility issues to use voice commands, for example. Speech-to-text and text-to-speech applications have been there for a while, and they've been assisting users with visual or hearing impairments. Chatbots, every application that you go nowadays has a chatbot, right? That is often powered by NLP. And a good conversational support in multiple language support, for example, benefits users with cognitive disabilities as well. Also, predictive text and autocomplete features powered by AI can help people that have motor skill issues or have dyslexia. And as I said, the language translations, can break down the barriers when the language is there, and it can enhance accessibility for those that are not native speakers. AI can help when it comes to computer vision. For blind users, think about it. Screen readers cannot describe images without the context. But AI can read images, right? Can look at the images and can interpret a graph, can explain that in plain language. And there are various clients. I think that Google has one. There's one SDK from Azure for computer vision that is also written in Java that you can integrate. And those can be used to integrate in your application and to help explain images and charts that are going on with your application for the users that have disabilities. Voice interfaces and assistive AI. Well, voice interfaces make your application more hands-free, more inclusive. And if you have translation features, you can bridge the language barriers too. And I think there's something called like deep speech in Java. There's like a lot of speech-to-text offerings with different cloud providers, and of course more SDKs coming from that. If we are to bring all this together, AI and what we have, we should use AI where it helps. Text, voice, vision. But we should always follow up with real-world testing, meaning test with people. Now, Java is pretty mature and has a solid ecosystem and can be a solid base to build on when it comes to AI and when it comes to integrating with AI. But always, always validate that integration with real people. And finally, accessibility is everyone's responsibility. It's not just one-time thing. You should test early that your application is accessible. Don't wait until it's the final delivery of something and then see if it's accessible or not. You should test often. You should not wait for the fine to come over. And also, you should think about including everyone. Think about how Java can help with the accessibility support it has, with the patterns that are available in architecture and so on. And also, how can AI enhance but not replace the human-centered design of your application? If you want to hear more about Java, we have a lot of ways to connect with you. We're on YouTube, but we're also on dev.java and inside.java. And those websites, we're continuously monitoring them for accessibility, by the way. So because we're maintaining the websites, we're really concerned about accessibility and having it keyboard navigation and available and interactive as possible and available for screen readers. So those are the first places where I test personally the accessibility part. But in there, we're publishing a lot of tutorials on Java in general, on best practices, and what's going on with Java in terms of news and so on. If you want the slides for this presentation, they're here. I'd like to thank you. Gracias, gracias. And I'm looking forward to have your questions or have your feedback, but also talk to you more throughout the conference. I'm here all day. And talk about what's the hardest accessibility issue that you faced, or if you're using screen readers for testing, what you're using to assess accessibility and so on, and if you know the accessibility level of the applications that you're working on. Thank you for listening to me.